Okay, so we're supposed to be calculating quartiles for this problem. Oops, let me get a different version. That's okay. We'll just pick it up from here. When it says using technology, I just use StatCrunch because it's already built into my math lab. And then, I mean, I'm always happy to help you. StatCrunch isn't something I use all the time, but I'm pretty familiar with it. If you ever want to know where a function is, just send me a quick message and I'll hopefully be able to get it pretty quick. But we're looking for quartiles, so that sounds like a summary statistic to me. So let's go to stat, because we want to make some statistics calculations. Go down to summary stats, and our data is in columns. I'm looking for var1. That's my only column I have going on. And I want these two summary stats. So I held control on it on my keyboard to select two. That's how I get 27 and 37 from technology. Okay, part B says find quartiles using the Tukey method. So, I mean, this debate isn't usually had too often, but there's two different ways of calculating the quartiles of a data set with an odd number of data points. Tukey's method is the same as as like what's typically taught in schools, I'd say, if there's an if there's an even number of data points. But where Tukey's method differs is when you have an odd number. So I'll show you what I mean. We got our data set here. If we sort this from least to greatest, by the way, I'm doing this in Google Sheets. You can do it in Excel. It should be the same thing. I sort it from least to greatest. So my middle number is going to be right here at 32, right? You could check real quick with a calculator. You could type equals median, and it's from, I don't know why I'm in column O, but I am. Column O, it's cell O1 to O25. That's our median of our data set. Calculate that. By the way, the median is called Q2. It's the second quartile. It splits it up into two 25% chunks, right? There's the 25 and 25% chunk that represent the lower half and the upper half. It's like the 50% cutoff. So the median is called Q2. So to find Q1, what we usually do is we split the data set based on the median. And what's traditionally taught in American schools is you take these data values and exclude the median. That's your lower half of your data set. And then you calculate the median of that lower half. Okay? Tukey's method is different. Tukey's method doesn't say exclude the mean. Tukey's method says take the mean. I said mean, but the median. Tukey's method says you include the median when you calculate the lower quartile. So with Tukey's method, we're getting 27 for Q1 because that is the median of the lower half of the data set. And then we want the median of the upper half of the data set. So let me take the upper half of the data set, including the median itself from the original data point, from the original data set. And so we want equals med for median. Starts on V1 and then colon V13. That's the median of the upper half. The median of the lower half, that's called Q1. That's 27. Median of the upper half was 37. And that happens to be the same for this data set, but it's likely if you were to try this problem a couple of times, you get some data sets that aren't the same. Okay, but the big point the problem is trying to emphasize is that your software, I think, uses what's taught in American schools, which is where when you find the median of the lower half to find Q1, you exclude the median of the entire data set. You would exclude 32 and then just calculate a median for this. With Tukey's method, you take the median and it's a member of both the lower half and the upper half. And there's no right answer. From what I understand, statisticians can't agree on what's the best way to calculate Q1, Q2, and Q3. Okay, they want us to find IQR from part B. The interquartile range is just Q3 subtracted by Q1. And that tells you there's a spread of 10 units between the lower 25% and the upper 25%. The upper 25% of the data set. And standard deviation, let's see if I messed up my data set. Looks like it's all there. If you're in Excel or if you're in Google Sheets, it's pretty quick. It should be under that stat menu if you're using StatCrunch. Either way, whatever you want to do, stdev.p or .s. You'd use .s in most cases because .s means the sample standard deviation. the sample standard deviation and the population standard deviation are slightly different. You want to be careful about when to use that. You use the sample standard deviation if you didn't get everyone in your population. And surely they didn't ask every internet user, right? We don't have the entire data set of internet users. We just took a small sample. So that's why I'm using stdv.s. That's what I got for standard deviation, and they want it to 3 decimal places. So I'm going to round down.